No one becomes great in a day. No one becomes confident overnight. Strength is not a gift, it's a result. It comes from doing something again and again. If you wait for the perfect mood, the perfect time, or the perfect mindset, you will be waiting forever. The real magic happens when you keep going even on the days you feel like quitting. And that's how the progress happens. And now let's begin our video with test of significance of small samples, single mean. See here, when the mean is not given and standard deviation is not given, so we have to go with the student t-test. This is of second type. In my previous video, I have taught you till example 5. In today's video, I am going with example 6. Producer of gutka claims that the nicotine content in his gutka on the average is 1.83 mg. Can this claim accepted if the random sample of 8 gutka of this type have the nicotine content of, see here, 2, 1.7, 2.1, 1.9, 2.2, 2.1, 2.0, comma 1, 1.6 mg. So we have to use a 0.05 level of significance. So what is given and what is to be proved? See here, n is also not given. So we have to calculate 1, 2, 3, 4, 5, 6, 7, 8. So that from the data, n value is equal to clearly 8 and mu is equal to 1.83 mg. And now we have to calculate mean as well as standard deviation. First, see here, in order to calculate the mean, so what will be the mean here? So we have to add up all these. Mean is equal to, see, x bar is equal to, this is a sigma x by n. So what will be sigma x? This is 2.0 plus 1.7 plus 2.1 plus 1.9 plus 2.2 plus 2.1 plus 2.0 plus 1.6 divided by the value n is equal to 8. So after calculating, our x bar value here is 15.6 by 8. This is 1.95. This is our mean value. So the mean value here is 15.6 divided by 8, which is equal to, this is 1.95. Clear? So we have to add the given data divided by the number of data observations, 8. And next one is we have to go with standard deviation. So in order to calculate the standard deviation, this is the table, this is x. So all the values are filled in the first column, that is 2.0 till 1.6 from this data given. And the next one is x bar. X bar is nothing but 1.95. So we have to subtract x minus 1.95. So we have to subtract from each and every value of x. That is 2 minus 1.95 is 0.05, 1.7 minus 1.95 is minus 0.25, 2.1 minus 1.95 is 0.15, and this column is filled like this for subtracting x values from 1.95. And the next one is we have to make the squares out of this. 0.05 whole square is this one, minus 0.25 whole square is 0.0625, and so on. So after adding, so the value here is 0.3. And how to calculate this? Variance s square is equal to sigma x minus x bar whole square by n minus 1. Here it is very clear that n value is equal to 8. So what is the summation value? The summation value is 0.3 divided by 8 minus 1. This value is 7. So here s square is equal to 0.3 by 7 and s value is equal to, so if you make a square root with this value, so this is 0.21. So we got the standard deviation value as a 0.21. Clear? And the next one, so we have to check the claim. First, we have to go with the null hypothesis. The first step here is the null hypothesis. Mu is equal to 1.83 mg is given. Alternate hypothesis, mu not equal to 1.83. Level of significance here from this is 0.05 level. And the next one, test statistics. And this is the formula, that is t is equal to x bar minus mu by standard deviation by root n. So here, if I substitute the same formula here, that is t bar is equal to, so t is equal to, this is x bar minus mu by s by root n. So what is our x bar value? 1.95. Mu value is equal to, see from the question it is 1.83. S standard deviation value is 0.21 divided by root n value is root 8. So here, after keeping everything in the formula, so the value here is 1.62. And next one is level of significance. At 0.01 level of significance, degrees of freedom n minus 1, 8 minus 1, this is 7 degrees of freedom. So we have to go with the student t-test table. So this is the table value from degrees of freedom. N value is equal to 7. So the value here is 1.895. I'll show you. At this 1.895 at 0.05 level of significance for 7 degrees of freedom, the value is 1.895. So this is the tabular value. So the tabular value here is 1.895. So this is the calculated value. When you compare the calculated value and the tabular value, so clearly the calculated value is less than the tabular value, and therefore if it is less than, so we have to accept this one null hypothesis. The null hypothesis may be accepted at 5% level of significance. And then what will be the conclusion here? We may conclude that the data are consistent with the assumptions of Gutka on an average of 1.83 mg. So is it not clear? So here, when you observe, only the data is given. So we have to calculate the mean as well as the standard deviation, and we have to go with the 5 steps. First one is null hypothesis, alternate hypothesis, level of significance, the test statistics, and the conclusion part. So each and every time we have to take all the 5 steps. And here is the 7th example here. 8 students were given a test in statistics, and after 1 month coaching, they were given another test of the similar nature. The following table gives the increase one of their marks in the second test over the first. Students, the number of students are 8 here. The increase in the marks from the first test to second test is 4, minus 2, 6, minus 8, 12, 5, minus 7, 2. And next, what is it? It is asked, do the marks indicate that the students have gained from the coaching? So this is the question. So from this data we have to calculate. So only n value is equal to 8 is clearly seen from this table. And now we have to calculate the mean value as well as the standard deviation value. For calculating the mean, the formula here is sigma x I by 8. So 4 minus 2 plus 8 plus 6 minus 8 plus 12 plus 5 minus 7 plus 2 by the number of students 8. So here the value x bar is very clear as 1.5. And next one we have to calculate the standard deviation. For that, first s square is equal to 1 by n minus 1 into sigma x minus x bar whole square. So what is our x bar here? 1.5. So we have to subtract from each and every observation, that is 4 minus 1.5 whole square plus minus 2 minus 1.5 whole square. Next, plus 6 minus 1.5 whole square plus minus 8 minus 1.5 whole square plus this is 12 minus 1.5 whole square plus this is 5 minus 1.5 whole square plus minus 7 minus 1.5 whole square plus 2 minus 1.5 whole square. So this is the value. So if you divide, the value will be here. And now this value is nothing but s square. And now for standard deviation, we have to take the root out of it. And this value is 6.8. So we got the mean value as 1.5 and the standard deviation value from the data is 6.8. Clear? And now assuming that, so we have to assume that the students have not been benefited by the coaching. It implies that the mean of the difference of the two test mu is equal to 0. And see, this is the test statistics. The first one is the null hypothesis is the students have not been benefited. Alternate hypothesis, the students have been benefited. And the next one is test statistics. T is equal to x bar minus mu by s by, in general, this is n value. So this value is n. So here n value is equal to 8. And let me show you the values. Here x bar is equal to 1.5. Standard deviation value is 6.8. N value is clearly mentioned as 8. And the next one, mu value is equal to 0. So if I substitute the values and if I calculate using the calci, these values will be, this is 1.5 clearly divided by, see here, this is a 6.8 divided by, this value is root 8. So if you see, the value here will be 0.624. See clearly, this value will be 0.624. Clear? And the next one, the number of degrees of freedom value is n minus 1, which is equal to 7. So here for 7 degrees of freedom, if you go with 5% level of significance, so this is the table here. So at degrees of freedom 7, so we have to go with 5% level of significance at 7, n is equal to 7. This value will be at 7, the value here will be 2.365. So here this value is 2.36. So clearly, even it is 1.8 or 2.36, the calculated value is less than the tabular value. Clearly, the calculated value is less than the tabular value, and therefore it is not significant at 5% level of significance. So we have to reject the null hypothesis, and therefore the test provides no evidence that the students have been benefited by the coaching. And this is how we have to solve. Even it is n minus 1 also. So we'll be getting the calculated value is less than the tabular value, and don't worry. And so there are only two problems which they have taken as n minus 1. And so I made a correction in the textbook itself. And even though it is n minus 1 also, so we'll be getting the same result, and don't worry. And the next one, example 8, a random sample of 10 bags. Here it is clearly mentioned as the sample size is 10 of the pesticides are taken whose weights are 50, 49, 52, 44, 45, 48, 46, 45, 49, 45. Test. So now we have to test the average packing can be taken to be 50 kgs. So from this data, we have to calculate the mean as well as the standard deviation. So here the mu value is, we have to take as 50, and n value is clearly given as 10 bags, n is equal to 10. So first one is the null hypothesis. Null hypothesis is mu is equal to 50, alternate hypothesis mu not equal to 50. And in this test statistics also, I am going to use this value x bar minus mu by sigma by s by root n. So here what is x bar here? So we have to add up all these values divided by n, 10. That is 400, and this is 472 by 10, and this is 47.2. So we got the mean value as, this is 47.2 is our answer. Now we have to go with the standard deviation. And this is the variance, s square is equal to sigma x minus x bar whole square by n minus 1. So here all the values are taken from 47.2, that is 50 minus 47.2 whole square plus 49 minus 47.2 whole square plus 51 minus 47.2 whole square till here 45 minus 47.2 whole square. So this 50, 49, 51 so are taken from the given data. So this is 50, 49, 52, 49, 52, 44 and so on, 49, 48. So this is all the data taken and we have to subtract from 47.2 and here 50, 49. So this is 50, 49. This value is 52. So in the textbook itself there is some correction here. 44, 45 and 48. So take value as 52. And next one, so we have to add up all these values after making squares and we have to divide with n minus 1. That is 10 minus 1. So the value will be 6.1777. So this is the variance value s square. And now we have to take the square root. The value here is 2.48. So now we have to go with this one, test statistics, that is x bar minus mu by, this is sigma, that is standard deviation by root n. So if I take this value root n, so here they have taken n minus 1, so I am taking root n value. So what is x bar here? X bar is from this data, that is 47.2. So this is 47.2 minus mu value here is 50 from the question, and standard deviation value is equal to 2.48 divided by root n. N value is here is 10. So if I do with this, see here, this will be 47.2 minus 50 divided by, this is 2.48 divided by, this value is root 10. The value here will be minus 3.57 the value. So if I take modulus, so if I take modulus on both sides, so this will be 3.57. So remember, there is a note here, whenever we get the test statistic value which is greater than 3 or 3, so we have to reject the null hypothesis. So here the value of both root n minus 1 and root n are greater than 3, and therefore we are going to reject the null hypothesis and we have to accept the null hypothesis. So here is the part, and now we have to reject the null hypothesis and we have to accept the alternate hypothesis, and this is how we have to check with the 5 points, that is null hypothesis, alternate hypothesis, test statistics, level of significance, and the conclusion part. So there is no need of 5% level of significance. If directly it is greater than 3 or 3, so we have to reject the null hypothesis. And next one is stimulus administered to, see here, how many patients here? 12 patients resulted in the following changes in the blood pressure, that is 5, 2, 8. This is -130, -2, 1, 5, 0, 4, 6. Can it be concluded that the stimulus will be in general accompanied by an increase in the blood pressure? So this is the data given. So here how many values are there? 12 patients are there. So clearly we have to mention that n is equal to 12. N is equal to 12 and there is no other data here. And so we have to calculate the mean as well as the standard deviation. So mean value is equal to, we have to add up all the given values divided by n. 12, the value here is 2.58. So x bar we got as 2.58. Use your calci. And the next one variance here is sigma x minus x bar whole square by, the value here is n minus 1. So why they have taken this one n square? So this usually we have sigma x minus x bar whole square by, this value is n minus 1. So you have to keep it in this formula. And now, so we'll be getting the variance value, and after taking the root, this will be the standard deviation. See, in general, we have to subtract 2.58 from each and every value, that is 5 minus 2.58 whole square. Next one, 2 minus 2.58 whole square, and 8 minus 2.58 whole square, and this value is minus 1 minus 2.58 whole square till the last value here is 6. 6 minus 2.58 whole square divided by, here the value is in general n minus 1. N value here is 12, so we have to divide with the 11. And next one, so we have to take the square root out of this value. Please do the calculation. So approximately this value, the standard deviation value here given with 144 is this one. So with your value divided by 11 will be something. So I am telling in particular it will be the standard deviation value here is, this is 3.08. So I have taken directly from the textbook, and there are slight differences or mistakes here. Just I am correcting and telling you how to approach to the problem. And the next one is null hypothesis. Usually null hypothesis we have to take mu1 equal to mu2, alternate hypothesis mu1 not equal to mu2. See here, the mean value is 2.58, standard deviation value is 3.08, n value 12 and mu is equal to 0. So again this is the formula here, x bar minus mu by s by root n. So if you substitute all the values, the value here is 2.89. So here n value is equal to 12, n minus 1, 11 degrees of freedom at 5% level of significance. At 11 degrees of freedom at 5% level of significance, the value is 2.2. So here the value here is equal to 2.2 from the table. You will be getting the tabular values from the back side of the textbook. And now here the calculated value is 2.89 and the tabular value here is 2.2, and clearly the calculated value is greater than the tabular value, and therefore the null hypothesis here is rejected at 5% level of significance. And what is the conclusion part? So we have to conclude that the stimulus will be in general accompanied by an increase in the blood pressure. And this is how we have to do. And here is the 10th question. A new progress of producing asynthetic diamonds can be operated at a profitable level only if an average weight of a diamond is greater than 0.5 carat. To test the profitability of the process, 6 diamonds are produced with the weights of, so these are all the weights of the 6 diamonds carats respectively. Do the 6 measurements present sufficient evidence to indicate that the average weight of the diamonds produced by the process is in excess of 0.5 carats. So, do the 6 measurements present sufficient evidence to indicate that the average weight of the diamonds produced by the process is in excess of 0.5 carats. So here first of all we have to calculate the mean. Mean is equal to, we have to add up all these carats divided by the number of diamonds here are 6, and therefore x bar we got as 0.53. So x bar value is equal to, this is 0 point, this is 53. So this is the x column and this is x minus x bar. That is 0.45 minus 0.53 and 0.6 minus 0.53, 0.52 minus 0.53 and 0.49 minus 0.53 and so on. So we have to make a squares out of this, and after addition this is 0.0159 and its variance value is a sigma x minus x bar whole square by n minus 1. Here n, number of diamonds 6. So here n is equal to 6, n minus 1 will be divided by 5, and this is the variance value after taking the square root. The standard deviation SD value is equal to 0.056. Clear? So x bar is 0.53 and standard deviation value we got as 0.056. And next we have to go with the null hypothesis. In null hypothesis, the average weight of the diamonds is not greater than 0.5 carats, and alternate hypothesis mu greater than 0.5, level of significance 5% level of significance. Test statistics is very clear as x bar minus mu by s by root n. So what is our x bar? So here all the values are ready. X bar is nothing but 0.53. X bar is equal to, this is a 0.53. So if I substitute here, what is this? 0.53 minus, see here, mu value is equal to 0.5 divided by, what is our SD value? 0.056 divided by root 6. Root 6. So if I calculate, this will be 0.53 minus 0.5 divided by, so this is a 0.056 divided by, the value here is root 6. So if I close this, the value here will be the 1.312. The value here is 1. And clearly the value here is, if I substitute, this is 1.3122. And if you go with the degrees of freedom, that is n minus 1, that is 5 degrees of freedom at 5% level of significance. See here, at 5% level of significance, this is 2.015. So this value is 2.015. The value, if you compare with this, the calculated value is less than the tabular value, and therefore we are going to accept the null hypothesis. So if it's accepted, then what is the conclusion part? The conclusion part is, again, the average weight of the diamond is not greater than 0.5 carats. So here, this is the conclusion, and therefore, so here the calculated T doesn't fall within the rejection region, and therefore we cannot reject H0. Hence, the data do not give sufficient evidence to indicate that the mean diamond weight exceeds 0.5 carat. And say here, here is a note that the calculated value T does not fall within the rejection region. So within the rejection region, the value is not their calculated value, and therefore we cannot reject H0. So even though we got the less than value, so we are not going to reject, we are going to accept H0. So we accepted the H0, and therefore the average weight of the diamond is not greater than 0.5 carats. And thank you so much for watching, and it is very clear if you follow these two videos. So all the videos are posted in the playlist. If you follow one by one, clearly the textbook will be in your hands, and definitely you can score more, and you can do any problem of this kind. And here I have taught you two types with the single mean, and in my next video I'm going to take double mean, difference in means, and there are also two models here. Just I'm going to teach you from my next class. Thank you. Don't miss this video and pass it on to as many friends as you can. That is the greatest help needed to this channel, and thank you so much for staying.